Hello and welcome back. In example 3, we're going to continue looking at implicit differentiation. Example 3 says, find an equation of the tangent line to x cubed plus y cubed equals 6xy at 3, 3. That was actually the equation that was given as an example at the very beginning of the notes. So, not that it's very important. Let's go ahead and first, to get the equation for the tangent line, we need a point on the tangent line, which we have, that's 3, 3. And we need the slope of the tangent line. In other words, we need to find dy dx. So to find dy dx, we have this new technique called implicit differentiation, where, again, if you don't have y solved for as a function of x, then you just go ahead and you start taking derivatives of both sides of the equation with respect to x. And that's exactly what we're going to do. I'm going to write, just so I don't have to change colors so often, the dy dx's, and then I'll write the original terms given. So we have d dx of x cubed, which is just normal derivative using our derivative shortcut. 3 multiplies in front, you subtract 1 from the exponent to give you 2. See packet 5 for more details. Then see packet 6 for how we're going to do the next part. Remember that if the derivative, the variable you're taking the derivative with respect to is different from the variable that you see inside, right here, then you're going to use this implicit differentiation, which is going to involve a chain rule. So you're thinking about y as a function of x, some kind of function of x. It's related to x for sure by this equation, and at least locally it's some kind of function of x. So that's a function inside of the cubing function. We're going to use the chain rule. So here the 3 derivative of the outer, the 3 will multiply in front. You subtract 1 from the exponent, leaving the inside alone, the inside again being y right here, and then multiply by the derivative of the inside with respect to x. That's dy dx. Now on the right side, we have 6x times y. So that times is going to tell you that we have a product that we're dealing with here. 6x times y, that's the product of 6x and y. So we're going to use the product rule. We'll have first times derivative of second with respect to x, so dy dx, plus the derivative of the first times the second. So here I'm tagging the 6 along with the x. You could pull it out of the derivative if you wanted to and just focus on x times y and do the product rule there. But here I'm tagging the 6 along with the x, treating 6x as the first function. So again, let me just write it down. We're using the product rule here. And here, with the derivative of y cubed with respect to x, we're using the chain rule. Now we have a couple of dy dx's popping out. Let's bring them all over to one side, bring all the non-dy dx terms to the other side, and then we'll be able to solve for dy dx. So the 3y squared dy dx will stay on the left. You'll subtract the 6x dy dx to the left, and then subtract the 3x squared to the right. So you'll have 6y minus 3x squared. Now we can factor out a dy dx. And divide. Now, one more thing you could do as a step of simplification would be to divide the top and the bottom by 3. This is an optional step. It doesn't really change what the slopes of the tangent lines are. It doesn't change the derivatives, but it'll just make things simpler. I'm going to go ahead and do that. So divide top and bottom by 3, just to make things easier. We're going to have to plug something in to the derivative in a moment, so always nice to make things easier. Now, we said that the whole thing we wanted was the slope of the tangent line, so that we could then, with the point on the tangent line, get the equation for the tangent line. So we're almost there. To get the slope of the tangent line at 3, 3, we'll plug in 3, 3 into the derivative that we just found. And it turns out this all simplifies to -1. So, to write the equation for the tangent line, at 3, 3, fix that E. E deserves some respect. Very important number. To get the equation of a tangent line at 3, 3, we have a point slope form that we can use. Y minus y1 equals m, which is the slope, -1, times x minus x1. The x1 and y1 are the 3, -3 here. And you could leave it like that because it doesn't say any particular form, or just for grins I'll put it in slope-intercept form. So there's the tangent line. And this is the first time I've ever used the expression just for grins, and I caught it on camera too. That's great. Okay, so there's example 3. Thank you for watching, and see you next time.